Good morning, children. In previous class, we studied about pressure and did their units. Now today, we are going to learn pressure in fluids. So previously you learned what is meant by pressure. The rate of, pressure is defined as thrust per unit area. Pressure is defined as thrust per unit area. So unit area, now unit is Newton per meter square. So pressure unit is Newton per meter square. Now let us see, so what is meant by pressure in fluids. Before going to learn what is meant by fluids, first you should know where the pressure will be acting in solids. In solids, pressure will be acting at the base because the entire weight will be acting at one point. So in solids only in one direction this pressure will be present. Now if you consider liquids, so a substance which can flow are called as fluids, and all liquids and gases are comes under these fluids, and solid exerts pressure on surface due to its weight. Similarly, a fluid also exerts pressure due to its weight. A solid exerts pressure only on the surface on which it is placed, but at bottom, but a fluid exerts pressure on the bottom as well as on the walls of the container due to the tendency to flow. A fluid contained in a vessel exerts pressure at all points and on all in directions. Now let us see for this an experimental determination. So in the experimental demonstration, you see this, take a vessel filled with a liquid, you will consider water also, placed in a horizontal surface, make several small holes in the walls of the vessel, anywhere below the free surface of liquid, it is observed. Now the liquid spurts out through each hole like this. So let us see the diagram which explains this the experimental demonstration. Now if you observe this, now this cylinder is made some holes. So there is one hole here, another hole here. Through this liquid, if you observe this, here more depth is present. On this is surface of the liquid. So from there the depth is more. As depth increases, the distance also, the liquid or the water which is flowing also increases. That is due to the pressure. So pressure increases at the height increases. So at the surface, at the bottom, the pressure will be more than on the surface. So for that reason, now this experiment, if you put our finger on any of the holes, you will feel some thrust on that point where it is finger is kept. So thrust per unit area is nothing but called as pressure. Now if you note the distance from the bottom of the vessel to the point where the liquid from a hole strikes on the horizontal surface, it is noticed that at the depth of the hole below the free surface of liquid increases, the throw of liquid also increases. Here the liquid also will be, as the depth increases, the flow also will be more, distance will increase. That is this means that as we go down, pressure increases. Okay, as depth increases, pressure also increases. Due to that, the height increased, due to that pressure also increases. Next one is pressure exerted by liquid column. So how we get pressure is exerted at liquid column. So pressure P is equal to H rho G. H means height, rho means density, G means acceleration due to gravity. So consider a vessel containing a liquid of density rho. So let us take an example. Let the liquid be stationary in order to calculate the pressure at a depth H. Consider a horizontal circular surface PQ. Now this is PQ of area capital A at a depth h below the free surface xy of the liquid. Now the pressure on surface PQ will be due to the weight of the liquid column above the surface and the thrust exerted on surface PQ. Let us see this diagram. Now here there is a cylinder here. This entire is kept in trough, which is consisting of liquid. Now this is height h. So this is height h and PQ is the surface, and let the area of the surface be PQ. So surface area is A. So PQ is the entire. So that surface is PQ and it is present, the total area is present as A and depth is h. Now the thrust exerted on surface PQ is equal to weight of the liquid column PQRS. PQRS, that we say weight means nothing but mass into acceleration due to gravity, mg. Now the weight, W, instead of W, weight of mg, mass can be written as volume into density. Volume into density. So volume of the liquid column PQRS into density into acceleration. G means acceleration due to gravity. Instead of volume, we can write area of the base into height. Volume means we can write length into breadth into height. Length into breadth means nothing but area. So area into height is nothing but volume. So area of base into height into density into acceleration due to gravity. So A into h, that is area into height, into density means we can write rho as symbol. So rho into g. G means acceleration due to gravity. When you multiply all this, AH rho g will get. We get AH rho g, that is nothing but thrust. Now we want pressure. Pressure is equal to thrust by area. AH rho g by capital A. That AA gets cancelled. Will what is remained there? H rho g. H rho g is the pressure which is acting on the surface of the liquid. It is not the total pressure in the liquid. It is on the surface of the liquid. So total pressure in liquid at a depth h can be written as atmospheric pressure plus pressure due to the liquid column. Like if atmospheric pressure we consider as P naught, so P naught plus H rho g is the total pressure in a liquid at a depth h. Okay, so total pressure in liquid column at a depth h is equal to atmospheric pressure plus pressure due to the liquid column, that is equal to P naught plus H rho g. Next one, factors affecting the pressure at a point in the liquid. Previously only said pressure P is equal to H rho g. So what are the three factors means nothing but first one is free surface depth of the point h and density P, acceleration due to gravity G, H rho G. These are the three factors. If one changes, automatically pressure also changes. As the depth increases, pressure increases. As density of the liquid, that means when liquid changes, density also changes. Acceleration due to gravity will remains at certain place will be same. So G will not change. So acceleration due to gravity will be, if you consider as constant, only two factors will be left. One is height, another one is density. So if density of the liquid also, that means liquid does not change, automatically only one factor is left, that is height. So as depth changes, the pressure also changes. Next one, loss of liquid pressure. So what are the laws which are present for the liquid pressure? So inside the liquid, pressure increases with increase in the depth from its free surface. In stationary liquid, pressure is same at all points on the horizontal plane. Pressure is same in all directions about a point inside a liquid. Next point, pressure at depth, same depth is different in different liquids, because already said the density changes, the pressure also changes. It increases with the increase of density of liquid. So density increases, pressure also increases. And a liquid seeks its own level. Now, if you consider different shapes of objects will be connected with only one liquid. So when you pour in one liquid, so the liquid height will be same in all the things what the apparatus which we took connected with each other. That means level will not change. So it remains in the same level. For this reference, you can see the 8th class textbook. So in 8th class textbook, you are having this level to know a liquid seeks to one level is understandable by seeing the diagram. Next one, consequences of liquid pressure. Thickness of walls of a dam is increased towards the bottom. So what is the reason of increasing the walls of the dam increase towards the bottom? Because the pressure at a point due to the liquid pressure increases with the increase in height of the liquid column above it. So thickness of the walls of the dam is increased towards the bottom so as to withstand the increasing pressure of water. The arrows in the figure shows the increasing pressure towards the bottom of the dam. Now next one, like you can see the diagram for the understanding of this, how these dams will be constructed. Now if you observe this diagram, now the thickness of the dam is more at the bottom than at the above. This big arrow represents that the pressure will be more at this point. When you compare the as they are coming to the surface of the water above, the arrow size is also decreasing. That means pressure also decreases. So downwards pressure increases. When you come from below, the pressure decreases. So it depends upon the width of the wall will be more at the surface than at the above. Next one, water supply of consequences which takes place for this atmospheric pressure. One I said. Now second one, water supply of tank is placed high. You can see the water tank which is constructed so at the certain areas. So one water tank will be there beside that nearer to that area. So first the water will be filled in this. So it will be lifted through motors and here the water will be filled. Now afterwards what they will do is when they release the water from there, this water tanks will be more height than the normal buildings. So due to that, what happens, the entire water with the pressure, the water will travel and it comes up to the certain height in the houses, and even with a certain pressure the water will flow in from the taps. So why means because of the height. As height increases, pressure increases. So due to that, the greater is the height of the tank, more will be the pressure of the water in the taps. So due to that, for that reason only, the water tanks will be constructed so at certain height. Okay. Next one, diver suit. So what is meant? So diver means nothing but which he dives in sea need a special protective suit to wear, because in the deep sea the total pressure exerted to the diver's body is much more than his blood pressure withstand in it. So he or she needs to wear a special protective suit that will safeguards their body from the other pressure. So blood pressure will differ. So inside body blood pressure will be different, and the total pressure exerted from that outside will be different. For that reason, a protective suit will be used so as to safeguard from the this pressure from the outside. So diver suit will be safeguarded. So thank you. In the next class, we will see the next topic related to the consequences. Now we studied. Now in the next class, we will see about transmission of pressure in the liquids. That is Pascal's law. We will discuss about Pascal's law. Thank you.